Hello guys, I hope you're all doing well. My name is Walter, and today I'll be focusing on Sttn112 Introductory Descriptive Statistics. Okay, we'll be focusing on chapter 4. So with chapter 4, we are going to talk about the measures of descriptive measures of location. Descriptive measures of location, chapter 4. So now I want us now to start with this chapter 4. Okay, now we're going to talk about, remember, this module is Sttn112 Introductory Descriptive Statistics. Okay, now we're going to talk about chapter 4 here. We're going to talk about chapter 4. So with chapter 4, we are going to talk about the descriptive measures of location. Now, the descriptive measures of location, we have 4 types of descriptive measures of location. We have 4 types, which we have 1, I'll write it down, measures of location. The measures of location. Okay, the measures of location, sometimes they say the measures of central tendency. So if you are given a question and then they say measures of location or the measures of central tendency, just know that they are talking about the same thing. The measures of location or the measures of central tendency, the same thing. Okay, it's the same thing. Okay, now number 1, we have 4 types of measures of location or 4 types of measures of central tendency. So 1, we have arithmetic mean. You can just say a mean. 1, we have arithmetic mean. Okay, arithmetic mean. This one here. Arithmetic mean by this symbol here, it's x bar, this one here, we call it arithmetic mean, this one. And then 2, we have the mode. 2, we have mode. Which mode we are talking about? For mode, we are talking about the most frequent value in a data set. And then let's check this one. Okay, then 3, we have the median. We have median, option 3. Okay, median here. And then we have the median, this one here. Okay, we have the median. Okay, we have the median. With the median, we're talking about the center of the distribution when data is arranged in ascending or descending order, or from the smallest to the largest. Okay, and then the fourth one, we have the quartiles. We have the quartiles here. Okay, we have the quartiles. Okay. We have the quartiles. So now, since you all know that we have 4 types of measures of location or 4 types of measures of central tendency, we have only 4. 1, arithmetic mean, 2, mode, 3, median, 4, the quartiles. Now we have the 3 types of data that we are going to use, or that we are going to apply on this 4 types of measures of location, which now we have what? The 4 types of data that we are going to use. 4 types of data that we are going to use, which is 1, we are going to use ungrouped data. Ungrouped data, this one here. Ungrouped data. And then 2, we have grouped discrete data. This one here, discrete data. discrete data. Discrete data, this one here, just say this side, discrete data. And then the last one, we have grouped continuous data. Grouped continuous data, that's the third one. These are the three types of data that we are going to apply for us to calculate the mean, the median, the mode, and also the quartiles. Then the last one, we have the grouped continuous data. Grouped continuous data. Grouped continuous data. Continuous data. Continuous data. Continuous data. Then now, done with this one. Okay, now let's see now. Let's check. Now, okay, we can say now that we have three types of data: ungrouped data, grouped discrete data, and we have grouped continuous data. Now, I want us now to calculate the arithmetic mean. Arithmetic mean under the ungrouped data. Arithmetic mean under the ungrouped data. So now let's calculate this. Let's calculate arithmetic mean using ungrouped data. Let's start. Okay, let's start. Okay, number one, we're using what? Ungrouped data. Ungrouped data. Ungrouped data. Ungrouped data. Ungrouped data. This one here. Okay, then now let's use this one, and I want us to calculate. Okay, just do this. I want us to calculate the arithmetic mean for ungrouped data. Now for ungrouped data, for you to say that it's ungrouped data, you will be given a data set. Let's talk about a data. Let's talk about a data set. You will always be given what? You will always be given a data set. This one here. So for example, let's say now we have 3, and then 2, and then 9, and then we have 10, and then let's say we have 5, we have 6, and then we have 15. We have this. Okay, we have 3, 2, 9, 10, 5, and also we have 15. I hope you can all see that. Okay, under ungrouped data. Okay, let me just write 15 here. Okay, 15 under ungrouped data. So Roman figure 1, I want us now with Roman figure 1 to calculate the arithmetic mean by this symbol, which is the arithmetic mean. Now arithmetic mean is equal to, now since now we can all see that we are dealing with ungrouped data, so this is the formula that we are going to use. That's the summation of xi, the summation of xi divided by n. The summation of xi divided by n. So let me show you something here. When they are talking about the summation, it means that you add all these values here. You add 3 plus 2 plus 9 plus 10 plus 5 plus 6 plus 15. Okay, hope you all understand. We'll do that. Okay, let's do it. Okay, now we're going to add 3 plus 9. Let me just add 2 plus 2, and then plus 20, and then plus 3 plus 9 plus 2 plus, oh, it's not 20, so I made a mistake, it's 10. So plus 10, and then plus 5 plus 6 plus 5 plus 6 plus 15 plus 15. Okay, then we divided by what? Divided by, now with regards to the value of n, which we are talking about, the sample size or the number of observation, we count. Okay, we have 1, we have 2, we have 3, we have 4, 5, 6, and we have 7. You see, we have 7. Okay, then we divide by 7 here. We divide by 7. Then now let's do it on a calculator. Okay, we have 3 plus 9 plus 2 plus 10 plus 5 plus 6 plus 15, which will give you 50. Which will give you 50. Okay, 50, then 50 divided by 7. 50 divided by 7, then you'll get to at 50 divided by 7, then we'll get 7,14. If they say round off your final answer to 2 decimal place, then we get 7,14. This one here. Then that's your value of the mean. That's the first method that we can use. The second method that we can use, you can just enter your values on a calculator using a Casio. On your calculator Casio, you go to mode setup, then you'll see 5 options. Some of you will see 4 options, but some it's 5 options. It's fine. Then you go to option 2, which is STAT, STAT, which is that. You go to that, then you'll see 8 options. Some on your side you'll see 6 options. Okay, it's fine. Then you go to option 1, which is 1 minus var. After option 1, then what you do, you enter your values. You say 3. After 3, you press equal sign so that you move to the next step. Enter all your values. Then when you are done, then you press AC. Press AC on your calculator, then you'll see 0 there on your calculator. Then what you do now, you press shift, you press option 1, which you'll see 5 options. Now our focus now, since now we are required to calculate a mean, or since now we are required to calculate arithmetic mean, our focus now is on option 4, which is var. We go to option 4 var, then you see option 2, which is mean. You press that 2, you press equal sign, then you get your mean, which is 7.14. I hope you all understand that. Now let's move to Roman figure 2. Now Roman figure 2, now we are done with ungrouped data for mean. We are done with ungrouped data for arithmetic mean. Now let's focus on the mode. Let's focus on the mode. Remember, Roman figure 2, let's say Roman figure 2, the mode, Roman figure 2, Roman figure 2, Roman figure 2, which is the mode. Now the mode with this one here, Roman figure 2, the mode, we are talking about the most frequent value in a data set, which now let's use this data set here. We have 3, 2, 9, 10, 5, 6, 15. Let's add another value. Let's say we have 5 again. 5 again here. We have 5. Let me just do this. Let's say we have 5 again. Let's say we have 5 here. Let me just write it here. Let's say we have 5. We have 3, 2, 9, 10, 5, 6, 15, 5. If now let's say you're given a question, either on a multiple choice question or on a practical, just write it down, write that formula and so on. Then they say, what is the mode, or calculate the mode of this data set? And remember, for you to see that it's ungrouped data, you'll always be given a data set. Remember this, don't forget. Now what you do, because the mode you're focusing on the most frequent value in a data set, we check, okay? The most frequent value here in this case is 5. The most frequent value here, which is 5. 5 here, and then 5 here. Therefore, equal to 5. 5. Okay, hope you all understand that. Then we're done with the arithmetic mean mode for ungrouped data. Now we go to the median followed by the quartiles. Median followed by the quartiles. Then now let's look at the median here. Let's look at the median part. This is Roman figure 3. 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 We'll look at the median. The median. Okay, median here. The median. Now, okay, for the median, as you can all see that we are dealing with ungrouped data, or yes, ungrouped data, which from group data you can all see that, you can all know, understand that we are dealing with a data set. If they give you a data set, just know that you are dealing with ungrouped data. Okay, it's fine. Now here with the median, I always advise my student that when you are dealing with the median for ungrouped data, always calculate the position. The median here, then we say that the position of the median, which is equal to what? Which is equal to n then plus 1 divided by 2. This is the formula that you are going to use. Position of the median is equal to n plus 1 divided by 2. Okay, this is the formula that we are going to apply. Now, as all know that the median, we're talking about the center of the distribution when data is arranged in the center of the distribution when data is arranged in ascending or descending order, or when the data is arranged from the smallest to largest. It means that rule number 1, we have to group this data in ascending order. We have to group this data in ascending order. Let's look. We have 3, 2, 9, 10, 5, 6, 15, and 5. 15 and 5, then let's group it. we check. Okay, we start with 2 followed by 3. 2, we group our data set. Okay, 2, and then we have 3, and then we have 5, and then we have 5. Let's check if we have 6. Okay, we have 6, and then we have 9, 10. 6, 9, 10. Okay, 6, and then 9, and then 10. 6, 9, 10. And then now what else? We have 15. 15, 1, 2, 3, 4, 5, 6, 7, 8, which we have 8. So 10, 1, 2, 3, 4, 5, 6, 7, and then the last one is 15 here. It's 15. 15. Okay, sorry about that. Let me just remove this, erase this part. Okay, then meaning that we have 15 here. 15. Okay, the last one, it's fine. Let me just do it like this, which we have 15 in this case. Okay, hope everyone can see that. Okay, then now what do? We check. We want to work with the position. We want to work with the position. Then now we know the formula, n plus 1 divided by 2. How do we get the value of n? The number of observation of the sample size. We count. Okay, 1, 2, 3, 4, 5, 6, 7, 8. We can now see that the position of the median, which is equal to what? Which is equal to 8 plus 1 divided by 4. Divided by 2. So about that. Divide by 2, which will give you what? Which is, it's going to be 9 divided by 2. Then 9 divided by 2, it's 4,5. 4,5 here. 4,5. Now, since now it's 4,5, it means that the position of the median is on between position 4 and position 5, which we count. Okay, position 1, position 2, position 3, position 4, and position 5. Since now it's 4,5, which now we are going to take what? 1, 2, 3, 4, and 5, which now we are going to take 5 and 6. 5 and 6. Therefore, now we say that what? Therefore, the median is equal to what? The median is equal to 5 plus 6 divided by 2. 5 plus 6 divided by 2. 5 plus 6 divided by 2. Then you get your answer. 5 plus 6, you can just do it on your calculator. 5 plus 6 divided by 2, which will get 5.5 as your final answer for the median. Here it is, 5, let me just do this, 5,5. 5,5 as your final answer for the median. 5,5. Okay, as their final answer. So now we are done with arithmetic mean, mode, median for ungrouped data. Okay, we are done with median. I want us now to focus on the quartiles. Last one for the ungrouped data, the quartiles, which is Roman figure 4. Roman figure 4. Let me just check just to verify. Oh yeah, it's Roman figure 4. So with Roman figure 4, with the quartiles here, we have Q1, Q2, and Q3. The quartiles, Q1, Q2, and also you have Q3. Q3, which I can just do it like this, even this one like this, even this one like this. And also the mean, okay, this, which is that one. Now the quartiles, we have what we call the lower quartile or the first quartile, which they call it Q1, So for Q1 here, we are talking about the median of the lower half of an ordered data set. What do I mean by that? It means that with this one, always we look at the position. Remember, I always advise my students that if you're required to work with the median, lower quartile, upper quartile, and also the third quartile, which the second quartile, which is Q2, is the median in general. It's the median. Don't be confused by that. It's the median in general. So now, with the Q1, firstly, you have to calculate the position, which I can just say, okay, just write it here. Okay, position of Q1 here, which is equal to, now remember this, since now we are dealing with ungrouped data, we're going to use this formula, n plus 1, then divide by 4. N plus 1 divided by 4. This is the formula that we are going to use for us to calculate Q1, which is lower quartile. Okay, let me just do this, lower quartile. lower quartile. Okay, lower quartile. Okay, and then now what else? Then now we have what? We have Q2, and then Q2, remember, is the median. For this one, I hope everyone is okay with this. We are talking about the, or we are talking about the second quartile. So if you are given a question, then they say calculate the second quartile. Just know that they are talking about median with this one, the second quartile. Okay, second quartile, which the formula you all know, the position of Q2, which is equal to what? N plus 1 divided by 2. N plus 1 divided by 2. This is the formula that we use for ungrouped data. N plus 1 divided by 2. Okay. Now what else? Now we know the formula for lower quartile, and then second one, we know the formula for Q2, the median on the second quartile. Let's go to Q3, which is the upper quartile or the third quartile. Upper quartile or the third, let me just say upper quartile. Let me just write upper quartile. Upper quartile. Upper quartile. Upper quartile. This one here. Okay, upper quartile, which is this one here. Okay, upper quartile, which we are talking about what? Q3 or the third quartile. Position of Q3, which is equal to 3n. 3n divided by 3n plus 1 divided by 4, which is going to be like this. We use this to calculate the position. The position will help us to find our values for both Q1, Q2, and Q3. So it's going to be like this. It's going to be like this. Okay, then what else? Now we are done. We know the formula for Q1, Q2, and Q3. So now let's calculate Q1 and Q3, because already we know how to calculate the median here. Okay, okay, let's use that data. 235. Now you see, now with the lower quartile, upper quartile, in general, let me just talk about the quartiles. When you're calculating the quartile, make sure that you group your data set from the smallest to largest, or make sure that you group your data set from ascending or descending order, which we are just going to take this one because already this one is grouped. 2, 3, 5, 5, 5, 6, 2, 3, 5, 5, 6, 9, 10, 15. I'll start with 2, 3, 5, 5, 5. Okay, let's use this one to calculate Q1. Let's use it, and then okay, we have 2, and then we have 3, and then we have 5, and then we have 5. Okay, 3, 5, 5, 2, 3, 5, 5, 6, 9, 10, 15, 6, 9, 10, 15. Okay, 6. Oh, this was the smaller one. Let me just write the bigger one. 6, 9, 10, 15. Okay, 6, 9, and then 10, and then 15. This one here, 15. Okay, let's calculate Q1 here. Let's calculate Q1. This one, in this case, using this. Don't forget, always think about the position. How do you get the position for Q1, which is lower quartile? The position here, the position of Q1, which is equal to n plus 1 divided by 4. N plus 1 divided by 4. Which here in this case, n is what? Already we've counted that. 1, 2, 3, 4, 5, 6, 7, 8. Which n is equal to 8. Then plus 1. Then divide by 4. Then you can just check it on your calculator, which is 8 plus 1 divided by 4. 8 plus 1 divided by 4, which will give you 2.25. 2.25. Now, be careful of this. Since now it's 2.25, that's the position. We know that it's on position 2 and 3. Position 2 and 3, but we are not going to say 3 plus 5 divided by 2, because if you look here, we have 2 decimals. So this is what we're going to do. We say, okay, therefore Q1, let me just erase this part. So about that, we're just going to say Q1 is equal to what? This is the formula that we are going to use. Please bear in mind. Q1 is equal to what? Q1 is equal to the second position. This formula that we're going to use, the second position plus. So this thing here, because you know that this thing originally is from position 2. So we say 2.25 minus 2. which will give you 0.25 here in this case. So it's gonna be just do this one here. Just erase that. It's gonna be 2.25 minus 2. 2.25 minus 2, which will give you 0.25. So it's going to be, therefore, Q1 is equal to the second position plus this 0.25 into, we know, don't forget, third position and also the second position. The second, and this one is the third. Okay, into the third position minus the second. Into third position minus the second position. Then now let's check. Okay, therefore Q1 is equal to the second position. If you check here in this case is 3, so the second position is equal to 3 plus 0 comma and then 25. Okay, 25 into the third position, it's 5, so it's going to be 5 minus the second position, which is 3. Then it's going to be like this. Therefore we conclude, therefore Q1 is equal to, then let's do it on a calculator. We say 3 plus 0.25 into 5 minus 3, which will give us 3.5. Then that's our value for Q1, 3.5. That's our value for Q1 here. Hope everyone now understand. Now let's move to Q3. Q3, how to calculate Q3? Because already for Q2, we are talking about the median, or the second quarter that we are talking about the median. Let's now calculate Q3. For Q3, we're still going to use the same method. If for Q3 the position we get maybe something like 3.35, as long as it's 2 decimal, we are just going to use this method here. Let's check. Let's calculate Q3. Let's calculate Q3. Okay, and then Q3. Okay, let me just remove this part. Okay, Q3 here is just gonna be like this. Q3, and then okay, Q3. Calculate the position of Q3, which is equal to what? Position of Q3 is equal to, okay, position of Q3 is equal to 3 into n plus 1 divided by 4 into n plus 1 divided by 4, which here in this case, and it's 8. So it's gonna be 3 into 8 plus 1 divided by 4. 3 into n plus 1 divided by 4. So it's 3 into 8 plus 1 divided by 4. 8 plus 1 divided by 4, which will give you, let's do it on a calculator, 3 into 8 plus 1 divided by 4, which will give you 6.75. 6.75. You see now it's 2 decimals. 6.75. Okay, just write it down like this. 6.75. Okay, 6.75. Okay, you can now say that, oh, it's 6.75. It means that the position of the upper quartile is on position 6 and 7. Okay, therefore Q3 is equal to, don't forget, since now it's 6.75, this thing is original from position 6 before it moves to position 7. So it's gonna be 6.75 minus 6, which will give you 0.75. 0.75 here. Okay, so it's Q3, which is equal to the sixth position here, plus that 0.75 here, 0.75 into the seventh position, because it's on position 6 and 7. Seventh position minus the sixth position here, sixth position. Then now we just substitute. Okay, therefore Q3 is equal to sixth position. Where is it? The sixth position. Okay, 1, 2, 3, 4, 5, 6, 7. So it's 9 and 10. So on position, this one is 7. So it's 9 and 10. So therefore Q3 is equal to what? 9 plus 0.75 into 10 minus 9. Then we substitute. Therefore the value of Q3 is equal to what? Let's do it. 9 plus 0.75 into 10 minus 9, which will give you 9.75. 9.75. Then that's your value for Q3, which is 9.75 9.75. Then that's how you calculate Q3. Now let me just give you another example about this thing of Q1, how to calculate Q1 and Q3. Okay, let me just use this one here so that everyone can see. Okay, let's use this one here on this side. Let's use it on this side here. On this side, let's say for example you calculate the position of Q1, and then you see with this one we got 3. Let's see, oh, this one here we got 2.25 as the position. So let's say here in this case we calculate the position and then you get 4.5 as your Q1. I want to show you something. As your Q1, then you get 4.5. Then now what you're going to do now, if you get the position of 4.5 here, then you're just going to check, okay, since now it's 1 decimal place, it means that I'm not going to use this method. We only use this method when we have 2 decimals. Since now it's 1 decimal, then it means that you're not going to use this method here. Then we check, it's 4.5. Okay, then you're just going to check, oh, position 1, 2. Let me just erase this part. Okay, let me just erase this part. Erase this part. Okay, position 4 and 5, which is this one, 5 plus 6 divided by 2. 5 plus 6 divided by 2. Therefore what? Therefore Q1. Okay, okay, let's do it like this. Okay, therefore position of Q1, which is equal to what? Which is equal to 5 plus 6 divided by 2. 5 plus 6 divided by 2. 5 plus 6 divided by 2. The position of Q1, which is equal to, okay, 5 plus 6 divided by 2. Then you get your answer for Q1 here. Same applies to Q3. If for Q3 you get 3.5, just use this method here. But if you get 2 decimals, you use this one here. I hope everyone now understand. Okay, let's go and check. For ungrouped data, we are done for ungrouped data. For ungrouped data, I've calculated mean, median, mode, and the quartiles. And then now we can move to group discrete data, this one here. Group discrete data, let's do it. Group discrete data as option 2. Grouped discrete data. Okay, let's use this one. Okay, number 2, we have grouped discrete data. Number 2, grouped discrete data. Grouped discrete data. Grouped discrete data. Grouped discrete data. Okay, just do it like that. Okay, let me just do it like that. Okay, and then grouped discrete data here. Hope everyone can see. Okay, group discrete data. So for group discrete data, you will always be given this table. Sometimes they can say number of students, or they can just say number of students as X. Okay, and then they give you the frequency here. They give you the frequency, then it's gonna be like this. It's gonna be like this. Okay, they put 0 here or 1. So 0, 1, and then 2, and then let's say we have 3. And then another frequency, let's say we have 4, and then we have 9, and then we have 2, and then we have, let's say 6. Yeah, let me just put it like that. And then we have something like this. We have something like this. Even this one here, the group discrete data, we're going to use it to calculate arithmetic mean, median, mode, but unfortunately we are not going to do the quartiles, because for group discrete data we only have the quartiles for that. We only have arithmetic mean, mode, and also the median. Okay, then now it's gonna be what? Then now let's calculate, we're going to figure out, let's calculate the arithmetic mean for group discrete data by this symbol here. By this symbol here. Okay, this one here, which is equal to Now let me show you something here. The formulas for where is it? Let's check this question paper. It's 2018. Okay, I'm gonna show you something. The formulas for ungrouped data, for grouped discrete, for grouped continuous. But I think I will explain the grouped continuous on a later stage when we get there. Just want to show you the formula for this. You will always be given the formulas. Let's check. You see this formula here. You see this one here. It's for ungrouped data. So most of you will be confused when you see that, oh, it's like this, but we don't have any. You can just, if you check, if you check on when I was explaining, it was the summation of xi divided by n. This is the same thing. If you can just say x, the summation of x divided by n, this is the same thing. And then for which one? This one here, it's for ungrouped. I mean, this one is for group discrete data, So this one is going to be the summation of fi multiplied by xi, multiplied by xi, something like this. Then divide by n. Then this one, this is the formula for the position for Q1. This one here, for Q1 here. And then this one is for median. Sometimes they call it Q2 or the second quartile. And then this one for here, it's for Q3. So this 3, 1, and then 2, 3, both of them are for ungrouped data when you're given a data set. Okay, hope you all understand that. Let's check this one here. Let's calculate the mean for this. Okay, for here in this case, we have the summation of the f and also x. Summation of what? The summation of the frequency multiplied by x, then divide by n, which is equal to, when we check here, f is 4, so it's going to be 4 multiplied by 0 into then plus, and then we have 9 multiplied by 1 and then plus, okay, and then plus what? Plus 2 multiplied by 2 multiplied by 2, and then plus 6 multiplied by 3 multiplied by 3. Then we divide by n. So you see, when I was explaining the ungrouped data, for n, number of observations, you just count. But here in this case, you are not going to do that. You're just going to add your frequencies. Remember, always. So which is equal to the total. You say 4 plus 9 plus 2 plus 6, which will give you 21. Then you're going to divide by 21. 21 here, 21. Okay. Then let's use it on a calculator and check the answer for that, which we have 4 multiplied by 0 plus into 9 multiplied by 1 plus into 2 multiplied by 2 plus into, we have 6 multiplied by 3. Then we divide by 21, which will give you 1,476. If they say round off your final answer to 2 decimal place, then you will have something like 1,48 as the mean here. This is how we calculate the mean for grouped discrete data. For group discrete data, you'll always be given something like this. Hope you all understand. Now let's move to the mode. The mode here. Let's move to the mode. Okay, let's move to the mode. Okay, for the mode, because we know that the mode you're talking about the most frequent value in a data set. When we're doing ungrouped data, we know that if you're given a data set, then you just check the most frequent value there on your data set. Then you just say, oh, I have maybe I have 2, 2, 2, 2, maybe 4 2s. Then you can just say therefore the mode is equal to 2. But here in this case, because we are dealing with grouped discrete data, we're not going to say that the mode is equal to this. With this one, we look at the highest frequency. Let me just do this. We look at the what? The highest frequency. So if you check here in this case, the highest frequency here is 9. It's 9. So meaning that the highest frequency leads you to the answer. Therefore, the mode is equal to 1. You can just conclude that therefore mode is equal to 1 here. That's how you calculate your mode for group discrete data. Hope you all understand. Now let's move to the median part. The median part. Okay, the median. Okay, the median here, the median part. For the median, for group discrete data, we are still going to use the same formula, which is n plus 1 for the position. N plus 1, then divide by 2. Then divide by 2. And already we know the value of n, which is 21. So it's going to be 21 divided by 2, which will give you what? 21 divided by 2, which will give you 10,5. Which will give you 10,5. So for this one, this 10,5 is not our median value, it's the position here in this case. Let me just highlight this. This is the position here. It's the position with this one here. Okay, let's check. Okay, is the position. How do you find the median for group discrete data? Okay, then here, this is the method that I want you guys to use it. I have the one that I'm going to show you, but I prefer you guys to use the second one, the second method. We have 0 force. Okay, let's do it. Okay, we have 0, 0, 0, 0. Okay, we have 0, 0. We just change this to this. And then what else? 1, 9. Okay, we have 1. Okay, 1. And then we have 1. And then we have 1. Okay, 1. And then we have 1. And then we have 1. And then we have 1. Just count 1, 2, 3, 4, 5, 6, 7. And then 8. And then 9. Okay, 9. Which is 2, 4, 6, 8, 9. There's no need for you to write all those values, like for example 2, 2. No, we just have to count, because here in this case we got 10,5. It means that the position of the median is on position 10 and position 11. We count. Okay, 1, 2, 3. There's no need for you to write all those things. 2, 3. Okay, 4, 5, 6, 7, 8, 9, 10, 11. Okay, you saw that. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, which is this one here. Then the median is equal to what? 1 plus 1 divided by 2. And 1 plus 1, which is 2 divided by 2, which will give you 1. Which will give you 1 here. Then that's your median. Remember, there's no need for you to write all those things here, like all of them. You just have to check the position. You just say, oh, it's 10,5. I'm just going to write 11 values. Then I take those 2 values, I divide them by 2. Therefore, the median is equal to 1 here. Then we are done for group discrete data, and also for ungrouped data here, this one here. Then we're only left with this one for grouped continuous data. For grouped continuous data, let's do it. Grouped continuous data, last one here. Okay, and then let's do it. Okay, for grouped continuous data, it's going to be like this. Grouped continuous data. Grouped continuous. Oh no, let me just write it like this. Grouped continuous data. I'll just do it like this. Grouped continuous data. Grouped continuous data. Continuous data. Grouped continuous data. So this video here for chapter 4, it's for those who are doing Sttn111, STTF112, and also for those who are doing 122. This one is for you guys to check it. Okay, for grouped continuous data, you will be given a table like this one, which have the intervals. The intervals here in this case, the intervals here, the intervals, which this one is a V. Let me just try to do it like this, which it's a V. Okay, that's the intervals. Okay, then now after the interval, then we have the frequency. Okay, then we have what? We have let's say we have 10. We have 10, and then we have 20 here, something like this, and then we have 10, 20, and then we have 20 to 30, 20 to 30. Okay, and then it's gonna be like this, and then you have 30 to 40, 30 to 40, which is gonna be like this. Okay, let me just leave it here. And then you have the frequency. Let's say you have 12, and then you have 9, and then you have 3. Okay, let's say we have something like this. Okay, then you see now the difference between ungrouped data. Ungrouped data set, they will always give you a data set. Group discrete data, they will give you that table 0, 1, 2, they give you the frequencies. And then what else? Grouped continuous data, they will give you the intervals here. Let's calculate the arithmetic mean for grouped continuous data, which is Roman figure 1. Roman figure 1, this is the formula that we are going to use, which is equal to the summation of f multiplied by the midpoint here. F multiplied by the midpoint. Then we divide by n. So immediately when you are given a table like this, just know for the n you don't count, you add your frequencies here. Then let's check. Therefore, the mean is equal to what? Let's calculate the number of observations or the sample size, which is 12 plus 9 plus 3, which will give you 24. Should give you 24 in this case, 24. Okay, that's great. And then now you can all see that they want the frequency and also the midpoint, meaning that we have to add a column here for midpoint. Column for midpoint. How do you calculate the midpoint? We say 10 plus 20 divided by 2, which is 15. 15 here in this case. And then now 20 plus 30 divided by 2, that's 50 divided by 2, which is 25. 25. And then now 30 plus 40. 30 plus 40 divided by 2, that's 70 divided by 2, which will give you 35. 35. Okay, then it's this one here, then we have this, and then what else? We have this. Okay, now we have our midpoint and we have the frequency. Already we're given that. But if you check, they say the summation here, the summation, it means that we have to add another column for frequency multiplied by the midpoint. Frequency multiplied by the midpoint. Okay, which now will have something like what? Which now will have something like 12 multiplied by 15. So 12 multiplied by 15, which will give you 180. You just write it here, 180. 180, okay? And then 9 multiplied by 25, then it's going to give us 225. 225. And then the last one, we have 3 multiplied by 35, which will give us 105. 105 here in this case. Okay, now we have what? We have the summation. We have to calculate the summation of Fm. The summation of Fm, which is equal to, we have to add this. We add them, 180 plus 225 plus 105, which will give you 510. 510 here, 510. Then now, okay, then we substitute. Okay, 510 divided by the value of n, which is what? 24. Which is 24. Therefore, you get what? Therefore, you can just do it on a calculator. 510 divided by 24. Then you'll get 21.25 as your mean. 21.25 here. 21.25 here. Then with the arithmetic mean, we are done for grouped continuous data. Then now let's look at the one for the mode. Let's talk about the mode. The mode, we are talking about the most frequent value in a data set. But here in this case, because we are dealing with grouped continuous data, remember the highest frequency leads you to the answer. Let's look at the highest frequency here in this case. Highest frequency is gonna be 12 here. 12. But we are not going to say that the mode is equal to 10 and 20. No. The mode now we say 10 plus 20, then divide by 2, which will give you 15. Therefore, the mode is equal to 15. This one here. And then another thing, let's talk about the modal interval. For the modal interval here, let me just write it here. The modal interval, the modal interval, the modal interval, which we are talking about this one, the modal interval. The modal interval is equal to 1. If you check here, you are talking about the intervals. We look at the highest frequency, which is 10 and 20. So therefore, for this one, the modal interval is 10 and 20. You see, 10 and 20. That's how you calculate the modal interval. And then now we're done with mode and modal interval. Now we are left with the median. The median. Okay, for the median. Now with this one here, the median. This is the formula that we are going to use for grouped continuous data, n divided by 2. This is the formula that we are going to use for grouped continuous data. Always remember this. Sorry about that. Always remember this, that for median of a grouped continuous data, we use n divided by 2. Then I will explain this one on a later stage, because this one we need to draw a graph. Then for the Q1, for the position of Q1, the position here, position of Q1 is equal to, it's n divided by 4. Since now we are dealing with grouped continuous data, it's n divided by 4. N divided by 4. Okay, then now what else? And then for Q3, which is upper quartile, is 3n divided by 4. 3n divided by 4. This is the formula that we are going to use. So for this one, and then also the last one here, with this one, unfortunately, you cannot find the median, lower quartile, and upper quartile using this thing here. You cannot find them here. Unfortunately, we must draw a graph, which you call it the cumulative frequency polygon graph. If we draw a cumulative frequency polygon graph, then we'll be able to get the median and also the Q1 and Q3 by drawing the cumulative frequency polygon graph. Let's draw it. Cumulative frequency polygon graph. Frequency polygon graph here. This is the graph that you're going to do it. Now let's check. Okay, then it's gonna be like this. It's gonna be like this. Okay, that's our graph. It's gonna be like this. Just do it like this. Okay, like this. Okay, like this, like this, like this. And then here we'll be talking about the intervals here. The intervals. We're talking about the intervals. This one is gonna be like this. So and then this side we'll be talking about the cumulative frequency. Let's add the column for cumulative frequency here. Column for cumulative frequency. Let me just use a different color for that. Column for cumulative frequency, which is capital letter F. So this one is a small letter f. This one here. This one is a small letter f. Small letter f, which is like this. Small letter f, even this one here, small letter f. This one here, small letter f. Then it's like this. It's like this. Okay, let's add the first frequency there. Here it was 12. It was 12. Oh, okay, let me just add this one here. The first frequency is what? 12. Then we start with 12. That's our cumulative frequency. The second one, we say 12 plus 9. We say 12 plus 9, which should give us 21. Should give us 21 here. 21. And the third one, we say 21 plus 3, which will give us 24. Which will give us 24. 24 here. 24. Then we are done with the cumulative frequency. Now, for you to see that your cumulative frequency is correct, you see it by the total here. The total frequency, the last one here, is equal to the total frequency. This one here. Okay, then let's draw a graph. We have 12, 21, 24. Then we can use the method of 5, 10, 15, 20, and 25. Okay, which here we can just say, okay, 5, and then I say 10, and then I say here it's 15. That's not drawn to scale, and then I say 20, and then I say 25. Then for the intervals, we are going to calculate the midpoint. For the interval, we are going to calculate the midpoint. Already we have the midpoint. I think we have 15, 35, 15, 25, 35, which you can use the method of, let's see, 5, 10, 15, 20, 25, 30, and I think we have 35. Okay, let me just do it like this. Okay, here I can just say we have 5. Oh, come on, not this one. Okay, then it's gonna be like this. I can just say we have 5 in this case, and then somewhere here we have 10. We have 10, and then I can raise this one here. And then now what else? Somewhere here I can just say we have 15, and then this one I can say we have 20, and then we have 25, and then we have 30, and then we have 35. Then we check. Okay, 5 and let's check. We have what? We have 12 and 15, 12 and 15, 12 and 15, which is somewhere here. Okay, the 10, then 11, 12, 13, 14. So 11, 12, it's somewhere here. 12 and 15, so it's somewhere here. The graph will look like this, somewhere here. Somewhere like the S shape. Somewhere like something like this. Let me just erase this part. The graph will look like this. Okay, something like this, because it's gonna be something like this. Okay, let's start it here. The graph will look like this. Yes, let's see, 24. Oh, it's supposed to be this way here. This way here. Just to be on the safe side, it's gonna be something like this. It's something like this. Remember, this thing is not shown to scale, so yeah, the graph will look like this. Okay, then now sometimes they can give you this graph, then they say calculate the median, the first quartile, the lower quartile. If you are given this graph, you need to find the value of n here, the value of n, which if you check, how do you see? By this, you see this thing here, the last one, you check it there, go there, you see, you go there, then I can say n is equal to 24. N is equal to 24. But if they don't give you a graph, they give you that table, they say calculate the median, first quartile, and also the third quartile, then it means that you have to draw this cumulative frequency polygon graph. Then now let's calculate the median. The median is equal to, the median is equal to what? N divided by 2. That's when I calculate the position. Then it's going to be 24 divided by 2. Then 24 divided by 2, then we'll get what? 24 divided by 2, then we'll get 12. So it means that the position of the median is on position 12. Let me just use a different color for that. Let me just use this one. On position 12. Okay, where is 12? This is 11, 12, 13, 14. I can just say 12 is somewhere here. 12. Here it is. The minute I reach here, then I go down. Then I can say 17. The median, therefore, median is equal to 17. Then this one here, as we're calculating the position, this one, the position. Therefore, median is equal to 17. Then let's find the position of Q1. The position of Q1 here, which is equal to n divided by 4, which we will say n is what? 24, then divided by 4. 24 divided by 4, which will give you, okay, sorry about that, which will give you n divided by 4. So n divided by 4, which will give you what? 24 divided by 4, that's 6. That's 6. Then we check it. There. Okay, let me just do this. Okay, which is 6. Okay, that's 6. Then let's check. 6. Let me just use a different color for that. Okay, let's see. No, I don't want this one. I want this one, which is 6. So if we check here, you can just say 6, 5, 6, 7, 8, and then 9. So 6, I can just sit somewhere here. You see, I go this side, then it's like somewhere here, then I go this side. So I can say the position of Q1, it's 14, probably 14, yes, 14. So therefore Q1 is equal to 14. So that's how you find Q1. Then what about Q3? Q3 is gonna be like this. Q3, position of Q3, which is equal to 3n divided by 4. So 3n divided by 4. Then we have what? We have 3 into 24. 3 into 24 divided by 4. 3 into 24 divided by 4. And then now what we have? We have what? Okay, we have this 3 into 24 divided by 4. Okay, then we have what? Okay, 3 into 24 divided by 4, which is 18. Okay, which is 18 here in this case. So that's the position. Therefore, Q3 is equal to what? Q3 is equal to, then you got 18 as the position. So here it's 15, and then 16, 17, 18, 19 here. 19 this side. So I can just say 18 is somewhere here. 18 is somewhere here. Then you see somewhere here. Then when I reach this side, then I go down, I go down, which is somewhere here. Let me just erase this line here. Okay, which is somewhere here. You can just say, oh, it's this line, go down, which I can say it's probably maybe 22. Yeah, therefore the value of Q3 is equal to 22. Then that's how you find, you can just say plus or minus 22. That's how you find those values on a calculator, plus or minus, and then this one, it's plus or minus. So let's do this one, plus or minus. So now we are done with chapter 4. So I hope you all understood. Please watch this video and follow for more videos, and please don't forget to subscribe to my YouTube channel. Thank you.